So I will introduce Roy while he sets up. We need to switch the computers here. As Tava already said, once we heard about Roy's work, we got mixed feelings. First of amazement and then maybe of some concern that maybe we will completely be unnecessary in the near future. But again, if to somehow characterize, I think, the attitude that most people here have, at least by random sampling, speaking with people, compared to what I hear from other faculties on campus, is that we really want to figure out how we can embrace AI and use it and enjoy what it has to give us. Some of the other faculties here are really, really scared that their students will stop working, everything will be written and done by the AI, and I think we have the better approach to this. So with this in mind, we will hear how you really, other than taking the data, if I understand correctly, AI does everything for you. Or at least the vision is somewhere over there. So Roy Kishony from the Technion, he's from the Faculty of Life Science or Biology, or how do you call it exactly? And he'll be telling us about the Data to Paper project.
Yofi, תודה על ההזמנה, thanks for the invitation, and thanks for putting up an event like that. I thought of it kind of makes me feel that I want to take notes and see how we do something similar at the Technion. My talk for today, I guess it can go in different levels, but okay. So for today, I want to tell you about kind of a journey through the last year or so, playing with AI, with ChatGPT in the context of science. And really what I want to show you is an completely autonomous platform that guides ChatGPT in an autonomous, automated way from raw data alone through all the scientific stages to final papers. And importantly, what I would advertise here is human verifiable papers, something we can actually read and understand and check. Okay. Verifiable is, by the way, it doesn't mean correct, it just means verifiable. Okay. The project was really carried out by these two really amazing people in my lab, Tali Fargan from data science, Lucas Hafner, who comes more with kind of biology background. The project is open source. You can go and install it and try it out. You know, we started, like everyone, we started playing with ChatGPT when it came out. And I was like, wow, I mean, it's really amazing. It can, it can write a story, it can compose a poet, it can answer questions. Can it actually do my job? Can it actually do science? So we kind of started to go through it. And I think a key for me was an aspect of science that is not just answering a scientific question, but rather, I think a key hallmark in scientific output is those ideas of transparency, traceability, verifiability, right? When we write a paper, it's not just here is the result, it's here is how we got to that result. Okay, so that, to me, these key hallmarks of scientific outputs that we want to see if we can preserve. Okay. So, of course, if you go to ChatGPT and say, hey, ChatGPT, here's my data, can you write me a paper? Nothing will happen. Oh, nothing good will happen, I can tell you that. And I think we've all had a share of experience with that. And you think about it more, and you say, yes, and I'm thinking about what Tova said about a mediocre student. A mediocre student, despite being mediocre, can still create a paper, okay? And ChatGPT cannot. And we were thinking about it, and we said, yes, it's because this little arrow that we have here is what we call scientific research. And scientific research is a very complicated process. It's complicated for us humans, it's complicated for AI. And the main thesis that we came with, that we kind of pushed us, and that what I want to put forward for today, is that perhaps we human can do it and ChatGPT cannot, and even a mediocre student can do it and ChatGPT cannot. Not only because we are smarter than ChatGPT, maybe we are, maybe we're not, I don't even know, but rather because we have a system. We have a system for how we go about science, scientific research. Okay. So what I want to do with you is think, what is that system? And can we imitate that system when we go to build an automated scientist? Okay. So we thought about it, and here's some, I would say, of the key hallmark of scientific research. It captures most of what we call science. First, this little arrow of data to paper is actually typically done in a multitude of steps, of series of steps, that even in fairly different research topics tend to be somewhat canonical, somewhat conserved. We start with thinking about a question, we look at the literature, we revise a question, we set a research goal, then we write a plan, then we go and execute the plan step by step, then we analyze it, look at the data, interpret the result, or some conclusions, and we start writing, which also goes in steps. Okay? So that's one. Second, also very basic and inherent in science, is that despite the fact that it kind of looks like a linear chain, it's never quite linear. We all know that. An inherent part of science is that you get stuck. And when you get stuck, you need to know what to do, how to reset, how to go back, how to rethink things. Also a key in scientific research. Then there is a question of interactions, right? We typically don't work alone. We have guidance from our professor, we have colleagues, we have a committee that give us comments, and so on. So there's this notion of different agents that interact with one another, okay? In each step, right, we produce something. We write a small report, we send it to a committee. There's an output. We call it like an intermediate scientific output from each step, and we use those research products as we go along. So there's a lot of kind of like respect to information, also very important in science. Then, of course, we don't work in a vacuum. We have external tools. We need to search the internet. We need to look for citations. We need to execute code, different tools. Okay. And finally, we are doing all of that in a notion and process that is aiming at producing what I mentioned earlier as scientific paper, which, if you think about it, is a very interesting document. It's a document that does it's the same document. It does two very different things. It tells us, hey, I found something, and hey, this is what you need to do if you want to reproduce what I've done in order to find that same thing. So for me, the key is to get to something like that. It has those two legs. So what we did, we kind of imitated all of that process in an automated computer package that we call data to paper. What it does, it takes data with annotation. It interacts with different ChatGPT agents, guides them through this entire process that I've shown you, and allows them access to external tools, write code, execute the code on the data, and at the end, boom, comes the paper out. And I think for the rest of the talk, what I want to do is two things. Discuss how it works, and then open some of these papers and look, what are they, how good are they, should we be scared, and so on. Kind of like take out the punchline. These papers are not going to be science or nature papers, okay? Don't worry. Okay. But they're going to be decent. Okay. So let's start from what the users see. The user comes, and there's an app. Like I said, you can try it on the web, or you should install it and try it. And you basically come and say, hey, I have this data set, describe the data set. Then you start uploading files. Each file you say what's in the file, what is each column, or whatever you want. And then you click start, and boom. it would go. You see on the different research step here, you see the discussion between the agents going on, and boom, boom, boom. It takes about an hour. After this hour, sit back, enjoy the show, you click, and you get a paper. Okay. No, there is an option for external interaction. I'll show you that. But this is fully autonomous, fully autonomous.
So 1 hour is background? 1 hour is background?
But 1 hour you can watch it, or you can go eat lunch and come back. It's the same thing. Yeah. Right. Not only that, every time you click the button, you'll get a different paper on the same data. Different question, different literature search, different analysis, different code, different table, different figures, different everything. Okay. So you can really, at that point I was like, I can publish one paper on this thing, or I can publish thousands of papers, but I had the choice. Okay. So I want to open that paper and some others. But before that, let's speak about how it actually works. Okay. So the way we think about it, we have to go through steps. And in each step, we are producing a research product. And I want to think about we are collecting those research products here. So how would it look? In the first step is, that's the only thing that is human. I've shown you the human describe what we have in the description of the data set. So we have one product. Okay. Go to the next step. It would go something like data to paper would tell ChatGPT, write a code to explore the data. Okay. The code will come out. I'll go into more details. I'm giving you the overview. Okay. You'll have a code. Data to paper will execute the code locally in the presence of the data and create some output. Go to the next step, research goal. Now I want to think about how each such step is implemented. Okay, so let's take the research goal. The idea is each step is essentially an independent discussion, okay? A conversation with ChatGPT, automated conversation. So research goal, essentially what we want is, hey, ChatGPT, write a research goal. More complicated, more detailed, but something like that, okay? But the key is we want to do it in the context of prior products that we've already gathered, okay? So the way we do it, we build a fake conversation that go, hey, I have this data. Don't ask me from where. I have this data set. I've done exploration, and this is what I got. Now, based on that, please write a research goal, okay? All of that conversation never happened. It's a fake conversation, but this is what gets sent to ChatGPT. Okay. So if you tell ChatGPT, hey, this is my data, this is my analysis, write a research goal, it would say, sure, I can write a research goal, and it would write something. And we instruct it to write in certain formats that we can kind of extract out programmatically our product, in that case, the research goal. And then we apply certain rule-based filters on that. For a research goal, it can be, it's too long, it's too short, it has keywords that we don't want to use, different things like that. Okay? Every time we violate a rule, it translates into an automated message that gets sent back. Hey, your research goal is too long. Hey, you should only focus on one goal and not many, different things like that. You're completely right. The focus here is on the stage of data science. First, it's in the scope of research that we would call data science research. There are many other types of research. And within that scope, there's a question of where the data came from, and are you involved in defining, or are you taking data that already exists? You can think about it as you've already collected the data for your own thoughts, and you are using the tool to analyze it. Or you can think about it as you have downloaded data that is public, and you want to ask questions about it. These are all legitimate ways. Can the system also participate in what should have been the data to gather? Of course, but it's not what we've done here. But what data to collect is also part of deciding on a research question, for sure. So here we're coming after that point. And because of that, when we talk about the novelty of these papers, we have to take into account the fact that a lot of what we call novelty of a research paper sometimes start and ends at how we gather the data. Okay. So here, when it's end, if I go and say, hey, these papers are not that novel, it should be taken with like a grain of salt because it's a function of what we fed it. Okay. If you feed it with novel data, you'll get novel papers. If you feed it with public data, you'll get less novel papers. Okay. So we said we have the rule-based agent, and after the rule-based agent is happy, we do another check. Just a second. We do another check for more content. And the way we do that, it's kind of fun. We open another conversation that goes in parallel. For an agent, we assign a task to be a reviewer of the other agent. And we let them exchange messages between them. So the reviewer would say, the research goal is too complex, cannot be studied with the data. Please correct. That message gets sent to the scientist. Scientists revise. The goal gets sent back, and they kind of interact with each other. It's really, really fun to see. I'll show you an example in a bit. When everyone is happy, you have the research product, you put it there, and you can go to the next step. Okay. Yes? The question was, when you choose a research goal, in particular steps that we talked about here, that was choosing a research goal, there is a tension between, you can ask something very simple, but boring, or something that would be too complex, interesting, but too complex to answer. And there's a trade-off there. And I think when we do science, we try to push, right? But it's almost like an art to identify the point where it's novel, but it's possible, right? And where does that art actually happen here? I'll say three things about it. One, there's a question of how we actually formulate that prompt here. And that prompt is a fairly long prompt that came from kind of our experience of like pushing it, but not pushing it too much and so on. So some of it is what comes in that prompt. Another is what is the instruction that we give the reviewers, so that which also like, do you focus this instruction on creating novelty, or do you focus it on asking a question that clearly can be answered from the data? Okay. And finally, what we actually do is, you see this assess goal novelty? On that step, it would actually go and do a literature search for papers related to the goal. And after that, it makes an assessment. There's a step of making an assessment. Is that goal novel compared to what's known from the literature? And if not, it would go back and revise based on the papers that it found already.
Just to say that novel is not necessarily
Novel
is not necessarily interesting.
Novel, interesting, right. But these words, if you say, it's not that ChatGPT does not know what's interesting, what's novel, but my sense, actually, if you want to take it to more like a conceptual level, is that novelty and interesting and kind of breakthroughs, we think about them as kind of something about kind of a spark in our mind. But if you think about it, a lot of time, novelty happens when you bring two things together. Two different areas, a method and a question that meet in a way. I want to say, if anyone knows a lot about everything, it's ChatGPT. So I think its capacity to bring together different things is maybe even higher than us. Okay. But yes, these research goals, it's up to a lot. If you formulate the question of write a research goal, it should be interesting and novel, but it should be possible to answer it within the data. That's what we do. Okay, I think we understand that. In reality, what we have is something more complex. We have about 20 different steps. The writing itself is done in multiple steps. There are two places where we're going to do a literature search to verify the goal and when we start writing. There are three places where we are writing code to explore the data, to analyze the data, to prepare tables for paper. The literature search itself is done in a comprehensive way. But so this is the whole picture. And I think, like I said, a key here is a control of information flow. So when I'm doing writing, maybe I need the analysis result, but maybe I don't need to know what happened in data exploration. Okay, so we kind of have a map of each step, what prior product we actually feed it. And in a way, when you feed it only what it needs, there's less room for like hallucination and doing things that you do, and making mistakes. Okay, so I want to touch on the two, on how the hardest parts, which are writing the codes, and also on the literature search. So for code writing, remember we said we have kind of a rule-based agent and an LLM, an AI agent. The rule-based agent for code, we've worked a lot on. It has there are many different rules that you have to apply in order to get a code that actually works. Because what happened? We're going to tell ChatGPT, hey, write me a code. Then we're going to take the code, data to paper, automatically going to take the code and run it locally in the presence of the data and hope that it works. Okay. You have to get the file names correct, you get to output correct, you have many things can go wrong, okay? So we kind of have a system like that. It takes the code, does some static checks, it has to go in certain section that we impose. Then it runs the code, and then it says, reports runtime errors. So, hey, you have a divide by 0 on line 7, please correct. And that goes back. And at the end, to write a code, that step itself is something like 20, 30, 40 iterations of there's a mistake here, mistake there, until we actually get something that works. There are certain guardrails on things that are not mistakes, but they just lead to something that doesn't quite work. For example, hey, you're doing a t-test on line 11, but the standard deviation is 0, so you cannot do it, okay? So many kind of checks like that we do. And the output itself, you forgot to create a table, the table is too long, different things like that, okay. After all of that happened, then we have also the LLM review, okay, that looks at the code and kind of give comments. And that can look something like that. For example, hey, write a code to analyze the data, maybe here it did the logistic regression, then this is part of a very long code, but this code gets sent to the reviewer, and the reviewer said, hey, you forgot to include confounding variables. So it goes back and it adds the confounding variables. It's really fun to see those interactions. It's really fun. Okay. I think when we just started it, the main reaction that I had from scientists that tried to use ChatGPT was, I asked it for references and it gave me a wrong reference. That was like, I'm not talking with it anymore because I asked it for a reference, it gave me a wrong reference. I want to say, if you ask yourself for a reference, you probably get a wrong reference. Not to mention you have to ask someone else. We don't do that, right? We have, as a Google Scholar, we do a search and we get a reference. So you kind of want to do the same thing. The same thing here. So what we actually do in the research step, in the literature review step, we ask it, hey, based on a research goal or based on the result, write queries for a search data set, a search database. Okay? Then data to paper go to Google Scholar or something else, semantic Scholar, run those searches and tell ChatGPT, okay, based on that search, I found these 100 papers. Which one is most relevant? Okay, that's how it actually goes. We also do kind of a fun thing that is also in AI, in the AI world. You can take when you're just starting to write a paper, and you have a kind of a draft of your abstract, you can embed that abstract in a kind of LLM embedding space. And then you can search for abstracts in the literature that are close in embedding space to what you're writing. So that's another way to search, which is quite powerful. Yeah, I was asked about human in the loop. So we kind of have two ways to approach it. And there's a question of what it can actually do fully autonomously, and also what it can do and how do, with human, and how would it look like when human and an automated machine actually interact to do science together? And I think that's, for me, is a very open question. I don't know how would it actually look like. I'll show you the little thing that we are trying right now, which is basically to think about human as kind of another agent that comes here. It can also give comments, and then the whole thing is, you kind of conclude when the rule-based is happy, the LLM reviewer is happy, and the human is happy. The way it actually goes is, like here, for example, it wrote a code that created that, and the human can say, hey, order the coefficient in different ways, and it would go and order them differently, and the data change. So you can come at different points and write comments, and those comments get sent as part of the discussion, and the LLM would respond to these comments and improve or change. Okay, so I think we understand more or less how it works, and now we want to do a pilot test case. In the test case, I want to show you data set. It's a questionnaire run by the CDC, Center for Disease Control. It's a phone questionnaire with some 20-something features, columns, and some 250 respondents on health behaviors that are related to diabetes. Are you running? How much are you eating? Do you like sugar? Different questions like that. Okay. And there's one column of whether the person actually has diabetes. I want to show you what will happen when we feed that data, and this test is going to be done without any human intervention. Just let it run. Like we said, we describe the data set. It's a CDC data set. I've downloaded it from here. Describe what is in each column in the file. Click that. I've shown you how it goes. Boom, boom, boom. We run. Again, we don't do anything. We just let it run. It goes through all the steps. You see here, that's a scientist. That's a reviewer here. That's a prompt to initiate each of the steps. But at the end, we click, and we get a paper. And now it's time to actually open it and think what's inside. So in this particular case, it shows, I think, something okay. I don't think, again, not earth-shaking, but a very reasonable question to ask on that data, how physical activity and blood pressure associate with diabetes, and stratifying by BMI categories, also looking for interaction, statistical interaction between these terms. Let's look at how it's actually written. So abstract typically is quite well written in the correct structure that we expect. Here is what we did. Here's the results of showing correlation, association of BMI prevalence with diabetes with BMI, and looking at physical activity, how it affects diabetes, and blood pressure, and so on. I want to say a lot of how this comes to look like something good is refining the prompt in a way that almost like, for me, it was almost like the experience that I have with guiding students, I want to say. It's like, here is how we write an abstract. It's not like ChatGPT write an abstract. ChatGPT write an abstract. Pay attention. Sentence number 1 need to introduce a subject, and it's important. Sentence number 2 need to introduce a research gap. Sentence number 3 introduce a method. Sentence number 4 say here we, and stuff. Like we actually give it. The prompts tend to be. It's kind of it's a magic. The prompts tend to be detailed but generic. Okay, that's the key. We want to give a lot of detail on what we want, but we want to keep it generic with respect to it should work on any type of data set and so on. Then introduction. We will see quite well written, well cited. These are citations tend to be in the right place, tend to get mostly the correct citations, and to put them in the correct place. You see this, for example, structure of different paragraphs that also imposed by how we write the prompt. But again, the prompt was written one time. It would run on all papers. How we write the prompt, and also on rule-based agents say, hey, you cannot have introduction to one paragraph. Hey, you forgot that. You didn't cite. Many rules that go into actually getting something looked at. Result section with actual display items. You can see how everything is very well explained, what was done here. It's a confidence interval. All of that is coming from, this is actually an output of code. We'll see the code in a second. But the fact that, everything is well explained comes from many rule-based responses that data to paper gives. Hey, you have a word that doesn't look familiar, explain what it is, different things like that. Okay, it looked at the diabetes prevalence in different BMI groups, started with that. Then a table of in different BMI groups, what is the average of blood pressure, you see it's increasing, of physical activity and so on. But then it said, okay, but let's build a linear regression model that it did here. Within each group, it's kind of interesting, stratifying the data within each group and looking at the contribution coefficient in the linear regression sense of physical activity, and high blood pressure, and their interaction, which it was non-significant interaction term. Continued with more tables. We won't go into the detail, but I do want to show you that everything like high BP, what it is, it's high blood pressure, okay? Yes, all of that, it's a paper you can read as a human and understand what is actually being shown. No, there are two checks. There's rule-based checks that I've written by hand in the algorithmic sense. Namely, for example, in the results, when it writes the results, there is a rule that it must cite every figure that it has. Okay, so algorithmically, I can check that it actually does that. If it doesn't, I say, hey, figure 2, you're presenting figure 2, but we didn't write a paragraph about it. Please write a paragraph about figure 2. And then these are algorithmic checks that comes from my experience looking at mistakes that it does and trying to think which of these mistakes I can algorithmically identify. Of course, there are many mistakes I cannot identify algorithmically, but that gives a structure to the whole thing. Okay. Then, after it passes all the rules, I give the result section to a reviewer, and the reviewer has instructions. And these instructions are also based on my experience in what type of mistakes the scientist is doing. Making evidence-less statements. Please search that all statements are correctly grounded in the data. Okay, if you see a statement is not correct, please identify and say what it is. Okay, so that's how it goes. Yes. Right. The question is, we have prompts for the scientists. We have prompts for reviewer, and we have rules that are programmatic. And what I'm telling you is that I have done all of the work of creating all of them. And what Tova is suggesting, maybe that part could also be automated. And yes, this is something fascinating for me. I can think of, I have different thoughts about how to approach it. None of them is conclusive enough that we've actually sat down to implement it. But yes, I would have loved to think about ways that it can kind of learn to become better for the next research, right? Because here, every time you click the button, you get a different paper, but there was no learning that happened in that process. Yes. Right. Yes. In a way, I'm trying to show you a system that I advertise as a generic black box that can take a data and create paper. Well, but the extent of how generic it is something I think that you're opening up here. And I want to say it's surely limited to the context of analysis of data, somewhat tabular, not exactly. Somewhat in the context of medical, because that was my mindset, and that these were the example I've given. Like I said, a lot of the rules are based on mistakes that I've seen, and they come from the example that I've fed it. So to draw the perimeter of the scope, that I think there is a question of to draw that perimeter, and then to say, okay, if I'm somewhere else, let's say now I want to do a paper that has to do with writing a computer simulation for something, not data, but computer simulation. Also, I think it's perfect, should be possible, but it means that this step process that I've shown you would be slightly different. Maybe there's additional step, maybe the prompts are slightly different. So I want to think about it. This is a platform on which you can develop other type of projects, okay? Right now, it's a platform that does data science type project in the clinical world. You can think about adding step, tweaking prompts, adding rules in order to do some other parts of science. Yes. Yes. Right. It's not only tabular. I'll show you an example where it's not. Limit is, there's no hard-coded limit, but the limit is, would you actually get something that is correct? If you start with complex data, my experience, it would make more mistakes. We'll talk about it. No, and I actually don't want people to use it as I've written that paper. I actually want it to be transparent that ChatGPT wrote that paper. They don't need to look here. It says it's written by AI. It has to be fully transparent. This is not human. Can you cheat? We can talk about cheating later. Yes, there are many ways to cheat, but this is not my goal. Is what you can do if you want to do things without cheating. Yes, okay. Okay, I'm cutting the question. We'll keep them to the end. Okay. So we went through result, discussion, also well cited. Then, importantly, methods, what exactly was done in each of the steps. And very importantly, okay, references, which again, by definition, they are legitimate. They're all valid references that come from a citation server. They're not invented, not hallucinated, nothing. Okay. References, 20 references seems reasonable. Data description, that's the only part that's a human-fed part, okay? Then the code that is written for data exploration, explanation of how the code works, the output of that code, then there's a code that is written for data analysis. You can see it's a fairly long code that creates all the table, that does the analysis, fairly long code. Then explanation of how this code works, the output. That's what ultimately starts to give look like the tables and figures that you've seen in the paper. But then it actually wrote a code to take that and create it into LaTeX tables and figures. And that was the output of that. And this is it. And then there's a note section that are very important. I'll get to that right now. Okay. Until now, I didn't get to my punchline. Okay? So time to actually kind of wake up. Until now, what we've done is to say, let's imitate human research, many aspects of human research, try to see how we imitate and automate them when we allow ChatGPT to do research. And in a way, what we are striving to is, can we do it as well as human? Okay. I want to show you something now that can maybe do better than human, actually better than human. Okay. Not just faster, better. And that brings me to really the key of, to me, the big drive in science is how is scientific traceability, transparency, reproducibility, okay? And when we come to think about AI in science, there is a fear, an inherent fear, that there is a trade-off. If I use more AI, I'm going to lose. Not going to understand, it's going to be non-verifiable, going to be flood of papers. Correct and very valid points. Okay. But I want to show you that maybe not. Okay. And the way to think about it is like that. Remember how we say that we, in a way, automate science through steps. And we say that when we go into every step, we use information from prior steps. So we kind of feed information forward. Okay. Now comes the beautiful trick. Turns out, not easy, but possible. I can talk with you about how it's actually done. But it's possible to invert that process and say for every word that I see in the paper, what information depended on in the past. Algorithmically, not AI, algorithmically. Because the data to paper feeds the AI with, it knows what it fed it at every point. Right? So we can kind of change things backwards. Okay? We can talk about how it's done, but I want to show you what happens, what it gives. What happens is that every time you have a figure, a number in the paper, it's hyperlinked like that. So for example, if it says, hey, physical activity reduces the odds of having diabetes with an odds ratio of 0.7233. And I'm a reader, I'm reading that, I'm just gonna say, okay, it's a statement, is it verifiable? Can I understand how it actually did it? Where is that number coming from? Okay. In data to paper, in papers created by data to paper, I can just go and, oops. Okay, I can go and just click, 0.7233, click, and takes me to a note section that say, hey, the number 0.7233, it's actually an exponent of some other number. And to explain, I'm calculating the odds ratio from logistic regression coefficient for physical activity. Okay, great, but do I believe this other number? Okay. So I can just go and click it. 0.324, click. I took it from this table, table 1. Yes, I can see it's a physical activity coefficient, but where is the table coming from? Do I believe the table? No problem, I can just go and click the table. Click. It's an output of the code. Here's the number I'm tracing. It's coming from this code output. How was that generated? Just go and click. Click, okay. Takes me to the specific line of code that created that. So I can look at it and say, yes, it's a logistic regression. Here are the coefficient. Here are the confounding factors. That's what created the table, and that's what created the number that was cited at the end. Okay. So for me, in a way, I want to think about it as defining a new standard for scientific traceability and reproducibility. That I kind of wish I could have written paper like that. I wish my student know that I strive and I nag them. How do we connect? How do we verify? How do we make sure people can reproduce? But it's hard. It's very hard to do it. Okay, and that's something where I feel like maybe there are ways to bring AI into science to help us exactly in that idea of connecting and making the paper completely traceable and making. Again, it doesn't mean that everything was correct. It just means we can verify all the process. Everything we can see, we can verify. Okay. Okay, so I think this way, by the way, going to be the slide I've worked on most in the entire talk, because my claim is the data to paper, in a way, it's kind of a gear. It's a gear that allows you to lift both of these at the same time. Okay. How are we doing with time? Few minutes. Okay. Few minutes. I want to talk about the scope of questions that it can answer, and also importantly, something about how likely it is to make mistakes. Okay. That's a big discussion. We can make. I'm not sure if there are many ways I can relate to that. I myself went through a transition as I was working with that, because when I tried to look for data that it can analyze and look for papers that are at that level, it just opened to me a big world of scientific publication that is probably, it's a pyramid. It's taking a big volume. It's good, solid, not high level, but good, solid publication. Sometimes very important. Could be, in a hospital, we had 20 patients, we gave them that, 10 patients, we gave them that, and here is what we see. Papers that could be highly impactful, but are very, very simple to write and to analyze and to write. A lot of the publication volume is there. A lot of what we, the taxpayers, surely the NIH is paying for, is not the Nature papers or science. It's foundation below. And my sense is, in that world, yes, many of the papers are fairly simple. They follow a template, and I want to say they can be automated to, with, especially when there is a human that actually looks and verify and check. Right, for systematic review and analysis, meta-analysis, there are not many, but there are a few very good tools that are being built, not by us. Like, for example, Perplexity, I don't know if people have played with. I think it's quite amazing to do. You ask a question, you get references, and there are other tools, and people have shown that these exceed human, like, if you take postdocs and ask them, find papers related to a topic compared to the AI, it does it better. Okay, it looks like I need to start summarizing. So I'll tell you what I didn't tell you, okay? Tell you what I didn't tell you, which is, okay, first that we talked about that every time we click the button, we get a new paper, okay? And I want to say, just like humanity doesn't have a tool to write paper, it also doesn't have a tool to review papers. So we ended up just reading a lot. We read like 100 manuscripts in order to try to evaluate. And we kind of like went each sentence correct, incorrect, like that. On the data set that I've shown you, it was all fine except for one kind of hallucination in data interpretation, result interpretation. So out of 5 papers, 1 wrong. But then we went like crazy with different data sets. People asked about non-tabular, so we took a social network, a graph data set of interactions between Congress members, totally different. We also took data sets from publications that were published after the horizon of the training of the model. So the model did not know about them. And we kind of told it, this is the data, and also that's a goal. I won't tell you what's a goal. Don't invent a goal, just do the research. Okay, so we can compare it one-to-one. So I don't know, there's something when you talk with ChatGPT about your own research and you're kind of amazed, but then there's a point where you make that switch in your mind where you say, okay, just as much as it knows about my own research, it knows about everything. So it's kind of like, okay. So on each one of these, it can write and analyze and know what's the questions. And so we did like several papers of each, read them all. It's kind of like in that range of, I would say, on simple, very important, on simple questions and simple data sets, it's about 80%, 90% correct. You can break it. You can make it fail if you just ask it something too complex. It won't. But very importantly, you can rescue these papers with a few comments from a human reviewer that comes and say, hey, this is something you're doing wrong, correct, and so on. Okay, conclusions. I've shown you a system, an automated system that does in a way, does what is we thought about as something very precious and very human. That is this notion of scientific research. Does it autonomously from data alone through all the research steps to final paper output. Importantly, these papers have what I would call human verifiable. We can read them, we can understand them, we can check them. We talked about the novelty, and we said it's okay, but like was pointed here, a lot of it depends on what you feed it. So if you have a novel data set, you'll get a novel paper. If you have a less novel data set, you get less novel paper. We talked about the fact that it's not proofed. It can make mistakes. You got to have a scientist that would actually check and verify. And I think mainly the key that I want to get across is that maybe AI can be kind of harnessed not just to do things faster, but actually to do things that we just can't do on our own, or that would be so tedious and hard for us, especially in this area of making science more transparent and verifiable. And I've shown you this idea of what we call data chaining, of connecting, tracing data downstream in a way that the paper itself is clickable upstream from statement to upstream code and data. Like I mentioned, the code is open. You are welcome to try it. You're welcome to contribute. You're welcome to develop and tweak it to your own type of research. And I'm also looking for comments. Thanks.
So maybe one very pressing question, if we still have one.
About?
Multiple comparisons.
Okay.
Yeah, so here you're trying to make
Right. Yeah, excellent point. So I want to say, the way we've built it is, think about a research goal, okay? You can revise it based on the literature, but once you go here, there is no going back. It's committed to actually test that research goal, test that question, and look at the result. And if the result is negative, no, the hypothesis is not correct, it would write a negative result research paper. So the system itself is not built to cheat. Now, we are saying, what if on top of that, I come with a higher level thing that call that function 1,000,000 times, and it would write 999 papers that are negative result, and one would be positive result, and I choose a positive result and publish it, you're welcome to do it. I have no control on that. And I want to say, in general, there are many ways to cheat in science. And with AI, there are even more ways to cheat in science. I think science is really built on trust at the end. Like, I'm not here to be a policeman I'm here to give tools to do things correctly. If you want to use these tools incorrectly, you can, yes. By the way, with generative AI, you can generate your own data also and write a paper about it. So it's limitless. It's at the end, it comes to how you what you want to do as a scientist. And I think we want to do good science, and we need the tools.
Okay, so we'll stop here, unfortunately. Okay. I want to thank Goy for a great talk.